Okay, welcome everybody. I hope you are having a wonderful afternoon. Let me just open up our page here. So, hello. I hope that you guys, as I said, are having a wonderful afternoon. Sorry, I shouldn't repeat myself a million times, but welcome to the grade 9, not the grade 9, the grade 11 class for the 21st of May. Today we're going to be focusing on some complex exponent law problems. And if you were here last week, we did a kind of review slash overview of the main exponent law problem types that you would see at the grade 11 level. So hopefully everybody can hear me okay. If you are having trouble hearing me, just let me know. And I will try to fix the stream. There we go. Okay. So, without further ado, hopefully we got that figured out. Anyways, so again, I want to just reiterate that we're going to be doing exponent laws today, but if you have other problems from your math class, you're more than welcome to leave the questions in the comments below, and we can take a look at any problems you might be having in your math class. Alrighty, so here we go. Okay, so last week, like I said, we were doing an overview of the problems that you would see, excuse me, for this unit. I apologize, I've been sneezing a lot today. My allergies are acting up, everybody. Just forgive me, I apologize again. So last week we did an overview of rational exponents and negative exponents. And today we're going to be focusing on building on those skills and really getting an understanding of how to do the more complex problems in this unit. Okay. Alrighty. So, like I said last week, these tend to get quite intense, and it's very easy to get freaked out by these types of questions because you look at them and they look so scary, and really our goal is to teach you guys how to simplify them in a way that is conducive to how you learn. So actually, before I move on to a really complex question, I'm just going to do a very quick overview for anyone who was not here last week. So when we talk about rational exponents, that means it's an exponent with a fraction. So say I had something with a base m and it's m to the power of 5 over 3. Another way of writing it, the more correct way of writing it, is the third root of m to the power of 5. So the denominator in the fraction actually goes inside the root. It's not a radical. That's something important for you guys to remember. It's not like radicals where you would put in the front as a coefficient. It is literally the third root, meaning it's kind of like where it's a square root where you're finding out what times itself equals the answer. In this case, it's asking what times itself equals the answer. And then basically you take the numerator and you put that as the exponent inside of the square, or the radical, I guess you could say. Okay, so I just wanted to go over that for anyone who might not have seen last week's session. If you did not, again, I stick around for today's, and then go ahead and watch back the lesson from last week. It's on our YouTube channel, and it should be much more helpful for you to kind of see everything like that. So let's do a somewhat easy problem. Let's go y times y to the negative 2 times x to the power of 5 over 3, all to the power of 2. So remember, with our product rule, our power rule, you need to multiply this square into all three exponents, and each of them kind of is going to be separate. But if we recall the rules of BEDMAS, we know that in actuality, because we have two bases that are exactly the same here, we're actually going to do that first. So let's go ahead and do the bracket multiplication first. So I have y to the power of 1 plus negative 2, and that's actually the most appropriate way to show it. especially for those of you looking to go into university. It's really important to show your work because most universities will require you to have some kind of testing where the TAs are marking you in that way, where they're actually looking for your steps. And so that's that. And then basically we get the answer of y, and then we go positive 1 minus 2, which is negative 1, times x 5 over 3. Now, this is where I used to get a lot of questions from tutoring students asking, well, shouldn't we put the y in the denominator because it's to the power of negative 1? And although that is the correct thing, it actually is going to be our last step that we do. So first we're going to do the brackets, we did the brackets first, then we're going to do the exponent on the outside. So I'm actually going to multiply this positive 2 in, and I'm going to get negative 1 times 2, x to the power of 5 over 3 times 2. And basically those brackets are kind of useless at this point, but that's okay. We get y to the negative 2 and x to the power of 10 over 3. So let's simplify this. We know that y is on the wrong side of the denominator, and technically this is all over the number 1. So what we want to do is bring y down. So I'm going to do that now. I'll show this here. X to the power of 10 over 3, and then y squared in the denominator. And it's really, really important that we show this step, because even though it's not our final answer, you're still demonstrating that this was its own step, and that will get you extra marks. And then basically, now I said it's not our final answer. Depending on your teacher, it might be. So if your teacher is someone who is okay with you leaving them as rational exponents, that's great, and I'm happy for you. If your teacher does not want you to leave it as a rational exponent, you can actually rewrite this as such. So it would be root 3, the third root, of x to the power of 10, and the y squared stays on the denominator. So either this or this is correct. They're both fine. But it depends on your teacher. And it just really comes down to the fact that every, math educator has their own way of answering things. In terms of which is technically more correct, I believe the lower one is technically more correct, like for the university level. But again, you might get a prof who doesn't care, or you might get a prof who explicitly says that they want you to leave things in rational exponent form. So it's totally up to you. This is a very important skill for those of you who are going into calculus at the university level. So calculus at the high school level, it's not that important, although it does matter on some level. Calculus at the university level, especially when we start to do something called integrals, which are my favorite part of calculus, but that's beyond the point. Really is based in our knowledge of this unit. And so I actually say that the most critical units in math, kind of all the way through from grade 9 to grade 12, are polynomials, graphing quadratics, and just graphing in general, trig, and exponent laws. Kind of everything else is really secondary. So if you don't have an understanding of these four main units, as you go through the various levels, you will have difficulty at the next level. So there's lots of rational practice sheets out there, you guys. I really recommend checking those out. There's a website called Kuta Software, Kuta. They're a really good resource, and they've got lots of practice sheets. Okay, let's do one that's a little bit more crazy, and let's talk about strategies. So this one has levels to it. Is that the phrase? Levels to it? I think it is. I'm just trying to believe it. Obviously. Okay. I'm trying to write this as large as I can, just because I know that there's a lot of numbers. Alrighty. So, like I said, when we're kind of going through questions like this, I found that in my tutoring endeavors, the main question that kids had for me was, what are the steps, what are the rules? Because teachers would just put a bunch of practice problems on the board, but never really explain what, why, how, where, all of that fun stuff. So I kind of like to break this down into steps. I highly recommend you write these down as we go along. I'm going to try to go at a good pace. If I go too quickly through the material, just stop me and let me know. I'm happy to reiterate anything that I've said before. So my first step is just to, pay attention to BEDMAS. And in BEDMAS, we need to do what's inside of the brackets. So that's our first thing we want to do, is just look in the brackets and see what can be simplified. Well, in here, I obviously have same bases, and I can go ahead and simplify them in that way. So I'm going to do that in my next step. So I'm going to leave it in brackets. I'm going to start with x. I like doing things in alphabetical order. I don't think it really matters though, again, because of the commutative property of math, it doesn't super matter, but that's neither here nor there. So okay, x to the power of a half. And then because this is a division, as we know due to the fact that it's a fraction, it's going to be minus -7 over 4. And then y to the -2. And remember that the whatever is in the numerator is going to be the first exponent number. So, and then that's -1 because in the numerator y is technically to the power of 1. And then we get +4 on the exponent there. Okay, so I'm going to move this up, you guys. If anyone needs me to move it back just so you can write it down, let me know. Alrighty. So now we're just going to go ahead and get these answers. If you want to show your teacher your step here, you can. So for example, like, making sure that you have the common denominator in the fractions. I personally recommend just like throwing every single step in. Honestly, if there's a step with 2 + 2, put that bad boy in there. You're getting marked for your steps, so it's totally worth it. That's like my #1 tip for high school students in general. Teachers actually give way more marks to people who have more steps than they do to people who have the right answer, because that's the way that they've been instructed to do what they've been instructed to do by the Ministry of Education, and that's how their marking scheme is set up, so that they can actually see whether you have algorithmic proficiency, which just means realistically whether or not you know what the steps are. Because I have seen many a genius math student, no joke. I have actually had tutoring students who are actually classified as math geniuses, that we've had to tutor on how to show their steps because they were losing so many marks not showing them because they were doing all the math in their heads. So that's my story of the day. I know it's not probably the most interesting story, but I mean, we're all locked in our homes, so what's really interesting anymore? It's all relative. I was going to say arbitrary. Okay, so from this point, we have simplified this stuff, and on to our step 2, which is bring in the exponent. Yay. So we're just going to multiply this exponent into both of these. And in this case, we get x4 times 9 over 4, which you can imagine cancels. And we get y to the -12. Actually, I don't even know why I did the bracket there. It's unnecessary because we no longer have it. So our final answer is actually x to the power of 9. And then because this y is to the -12, we've got to move that bad boy into the denominator, and it'll become +12. Yay! Yay! Creepiest smile of all time. Wonderful. Okay, so if everybody has a good understanding of that question, we're going to move on to something else. But yeah, so again, guys, my main tips for these types of questions are really to just, don't get freaked out by the immensity of the question. Oftentimes, it's actually much simpler than it seems. Just because there's a lot of numbers and letters doesn't mean that it's actually crazy. Let me just move this up so I can show you what I'm talking about. Like in this question, it looked quite complex when in actuality, we were able to simplify it right away. just by understanding what is a common denominator, what is not a common denominator, what is a common or like term, and then we kind of went from there. Alrighty, so another question that I would like us to cover, I'm just going to make a new page here. I'm going to change my pen color. And yeah, another question I would like us to cover is this type of question. So we've got 3x to the power of negative a half and 3x to the power of a half, y to the power of 1 over 3, and 3y to the negative 7 over 4. Okay, so in this case we don't have a power rule happening, but what we do have is a separated numerator and denominator. And what's very critical for us to understand is that in math in general, when you have a numerator separate from the denominator, which obviously is inherent in being a fraction, it's an inherent property of being a fraction, is what I'm trying to say, is that we need to deal with the numerator as if it has brackets and as if it's first. So basically another way of saying this, and actually depending on how nuts the question is, I sometimes recommend this to students to rewrite them like this. It just depends on what the question is and how you want to approach it. So this is the same thing as saying this. Okay, you don't have to rewrite it this way to get full marks. I just am showing this to you guys so that in the future, when you have questions such as these, you do apply this philosophy to it. Anyway, so like I said, this is not necessary. You just kind of have to understand that. Now, first things first, in the numerator, again, because we're basically quote unquote pretending that there's brackets around it, we have to solve anything that might be needing solving. That's, I don't know why I said it like that, but anyways. So in this case, we have two common bases. We have x, and their coefficients can be multiplied by each other. So we're going to get 9 x negative a half plus a half. And I'll show you guys what's going to happen in a quick second. So there's that. So obviously this becomes 0. And what happens here is that this becomes 9x to the power of 0 times y to the negative 1 over 3. That should be a 1. And 3y to the negative 7 over 4. Okay. So I'm just going to scratch that so no one gets confused. Now, at this point, what's really important to remember, and actually I'll give you guys a second to write that down if you're following along. Is that anything to the power of 0 becomes 1. It could be literally apple to the power of 0 and it becomes 1. So this, you actually want to show this step. So this becomes 1, the 9x to the power of 0. Because remember, this is all together, this part. And then this is y negative 1 over 3 over 3y 7 over 4. Great. And then in our next step, we just want to do that y subtraction. But what's really important to remember here, this is again one of those little notes I want you guys to make, a mental note, is do not change the coefficient placement at this point in time. So that stays the way it is. And we've got negative 1 over 3 minus negative 7 over 4. And obviously we're going to get a common denominator here. We're going to make that into 12. So if I've got 1y like this, so we're going to make this negative 4 over 12 plus negative or positive 21 over 12. And that's going to give us, finally here, let me just move this up a bit. That is going to give us y. Oh, sorry guys, 1 second. Oh, I actually wrote the original question wrong, but that's okay. I'm just going to give you the answer to the question I wrote, so that's fine. So in this case, the answer is y 17 over 12 over 3. Alrighty. So, I'll let you guys write that down. And just for anybody who needs to see higher up, this was the question we were working on. Okay. So, moving away from this question, let us do a real situation of a question that I've got here. Sorry guys, I have to look at these. There's no way I can memorize all of these questions. Then once we get started, I just kind of work on them as we go along. Okay, so in this problem, we have x to the negative a half times y to the 4 times a quarter over x 2 over 3 y 3 over 2 times x negative 3 over 2 y to the half. Okay, so as I said in the last question, we have to treat the numerator and denominator as separate entities, and then we deal with them afterwards. So let us go ahead and do so. Now, in this next part, what I'm going to do is worry about the denominator because I've got a multiplication in there. And in here, I could realistically bring this multiplication in if I wanted to. So I could show, for example, this is going to be x. Actually, I should get rid of the brackets completely. So actually, let's do the numerator first. We've got x to the negative 1 over 8, y to the 1, which technically just becomes 1 here. So the reason it becomes 1 is this, the y 4 times 1 over 4, those cancel. Okay, moving onwards. And then in the denominator, we are going to worry about this part here. So this becomes x to the power of 2 over 3 plus negative 3 over 2. Oh gosh, let me write this larger because it's going to be really hard for you guys to see. Let's go sideways for a second. So this part became x to the negative a half times 1 over 4, y to the 4 times 1 over 4, that canceled, and then that's going to give us an answer. And then I'll leave this part the same for right now. Okay. So the reason we're showing you guys these problems today and just why we didn't just stop at doing the simple examples last week was because realistically this is where you guys get those big marks on these tests. And even if you're not being marked on an examination this summer, I mean before the end of this semester, this is really a skill that you need for the rest of all of math. So I want to make sure that people understand how to approach these more complex problems. So anyways, so in the numerator, we're going to go down a step here. We'll get x to the power of negative 1 over 8, y by itself. Here we're going to get x to the power of 2 over 3 plus negative 3 over 2, y to the power of 3 over 2 plus a half. And if anyone is super lost and you're not feeling confident with your exponent laws, I really recommend going over some basic exponent laws. Ooh, sorry. Okay, so this gives us x to the power of 1 over 8, negative 1 over 8, y by itself. This is going to be a common denominator situation, so we're going to get x to the negative 5 over 6, y to the power of 2. Now, let's take a look from this point here. So, at this situation, now it's just a standard division, and we know what we do with our divisions. We go like this. We do a subtraction. So this becomes x to the power of negative 1 over 8 minus negative 5 over 6. And just be really cognizant of those subtraction situations. And then we've got y to the power of 1 minus 2. And our final answer is going to be a situation where obviously we need to do a common denominator. So we're going to go x to the negative 3 over 24 plus 20 over 24. Y is just negative 1 at this point. Again, leave that negative situation, the negative 1 on the y, you leave it until the very last step. Don't deal with the y at this point. Just keep focusing on getting a simplified exponent for x. Anytime you have a negative exponent like that, wait till the very end to fix it, okay? So then we get x to the power of 17 over 24 times y to the negative 1. And in the next step, you're going to go x to the power of 17 over 24 over y. And this is our final answer right here. And if we compare that, I'll let you guys write that down, but in a second we'll compare that to what the question was. So obviously this was quite a complex question in the sense that it had a lot of steps. It required a decent knowledge of all the rules. You know, these are things that I really hope you guys are able to ask me about in the chat if you do have questions, because now is the time to get a really, really good grasp on this stuff, okay? Cool. Just want to check one thing. While you guys are taking a look at that. All right. So, as you can see, we went from this crazy jumble to our final answer, which is quite a bit more simplified. And you're going to get questions like this on your tests and in future exams, because next year I'm assuming you guys are going to have exams again. So again, before we leave this question, I want to make sure that we understand some of the fundamentals behind this. First and foremost, treat the numerator and the denominator separately until you have simplified them fully. If there is math work to be done in either one of those two things, you have to deal with that stuff. Once you've dealt with it, then you can go ahead and start applying your quotient rule or whatever applicable rule is necessary. But my number one tip for these questions and these types of questions is to remember that BEDMAS is your number one guy. It really is. Okay, guys? So, I'm going to show you guys another concept that is also very important for the sake of this unit. One thing that we want you guys to be aware of when you're learning this material is that you can rewrite powers. So for example, in the same way that 16 can be written as 4 to the power of 2, well, we can also rewrite 16 to the power of 5 as 4 to the power of 2 to the power of 5. This is a very critical concept, and I'm going to show you guys why. But it's imperative that you understand that these can be manipulated, and oftentimes in math, that's what we do, is that we're constantly manipulating larger numbers to be more simplified, and that's actually going to be able to help us. So anytime you see a perfect square, typically that's what's going to happen. And when they ask you to evaluate an expression of this sort, it's really good to do that kind of backwards work. So actually the correct answer, the further correct answer to this problem here is 4 to the power of 2 times 5, which is 4 to the power of 10. And I actually think that it would be best for you guys to plug this into your calculator. So do 16 to the power of 5, right? You'll see that crazy large number that's over 1 million. And then go ahead and do 4 to the power of 10. And you'll get that same number. So it's very, very critical that we understand this, that we're able to manipulate these because there are a couple rules involved. So let's go ahead and take a look at some more problems in this vein. So you'll get questions all the time in this unit, and even in the grade 12 version of this unit. The grade 12 version of this unit is even more nuts. But evaluate without using a calculator. I'm also going to tell you guys that the earlier you start writing in shorthand like this, the better. When you get to university, some of your profs are going to be really, really fast speakers. And the best thing I ever did was teach myself some shorthand. I have all kinds of shorthand. Like if you see my real writing where I'm writing for myself or I'm writing notes for myself, literally you would not be able to decipher it unless you knew my shorthand. And that's one of the best ways to write university level notes. So for example, I use this as will, this as with, this as, what was this one? Which? And I have a bunch more like this and all of this stuff. Like it's just, again, a very fast way to write notes. Okay, point of the story. So you'll get questions where they say evaluate without using a calculator, which is fine. It's not a big deal. You might get questions like 5 to the negative 2 plus 10 to the negative 1. And in those types of questions, again, we know that these are on the wrong side of the denominator. So we get 5 to the power of 2 on the denominator. And then we get 1 over 10. And now in this case, we can break this down further to 1 over 25 plus 1 over 10. And we can simplify this further by doing a common denominator. So we could go 4 over 100 plus 10 over 100 and get 14 over 100. And then simplify that further as 7 over 50. So that's kind of a simple example. I'm teaching you guys these so that we can move on to the next concept, which is where it gets a little bit more insane. So the concept I really want to show you guys is that if you have a equality where the base is the same then the exponents also equal each other. And I'm going to show you what I mean because just seeing it as a word doesn't really make sense. So for example, if I said to you, b to the power of 5 is equal to b to the power of x, and then I asked you, what is x? It's quite apparent that x would be 5, right? Because if I'm saying these two things are equal, which I wrote them kind of wonky, let me fix that. If I'm saying these two things are equal, then obviously that is the same thing, right? It has to be. So x equals 5. This is all fun and games until things get a little bit more crazy. So the reason why it's important to know how to manipulate your exponents is for the purposes that we will be doing right now. So for example, if I said to you 4x plus 5, that's in the exponent, x to the power of 5 is the exponent of the number 4, of the base 4, is equal to 4 equals 10, I can actually just fully negate the 4's in this situation. And when I say negate, I mean just kind of ignore them. I'm going to focus in, pretend I'm zooming in just on the exponents, because typically the teacher will ask you to solve for the unknown. That's the type of question this will be. And in this case, I can ignore the 4s and I can just go right ahead and rewrite the exponents like this and solve algebraically. And again, this is kind of a simple version of this, but I'm building up to something, you guys, I promise. So x equals 5. And then a lot of times you would actually plug it back in and solve. So you're going to get versions of this, especially in grade 12, you're going to see quadratic versions of this, all sorts of situations. And it's very, very, very good for you guys to get a hold of this from the grade 11 level. Some teachers don't teach this at the grade 11 level. I've seen it in grade 11 textbooks, so I personally think it is important, and I actually think the earlier you get exposed to it, the better. But again, that's just my opinion. I'm nothing but a lowly tutor who has tutored this many, many times and has seen the same situations over and over again. So I don't want you guys to struggle. I want you guys to succeed. That's why we're going to kind of work our way up to a more complex problem here. Alrighty, so, whoops, my papers are flying everywhere. Sorry, guys. Okay, so now what we want to do is figure out the kind of problems where we would actually see that scenario play itself out. And you'll get questions like 4 to the power of 5x plus 30 equals, I'm making this up, guys, so bear with me. It might be a weird problem, but it's okay. 16 to the power of 10. And they're going to say, well, determine what x is. And you have to say to yourself, well, how can I make these into a singular base? How can I make these into the same base? And the way that we can do that is by understanding that 16 is the square of 4, is the perfect square of 4. So I can rewrite this. I'm just going to leave the left side as it is. And the right side is going to be rewritten as 4 to the power of 2 instead of 16. But I'm keeping the to the power of 10 because that's very important. So then I also have to go ahead and do that math. I have to do the power rule. And that becomes 4 to the power of 20. And then the 4s, because now we have a solid singular base, the 4s become irrelevant. And we can just go ahead and solve for this. And we will, again, like I said, I made this up on the spot, so it might be a wacky answer, but let's see. It's going to be 5x. Actually, it's not too bad. And x is going to be -2. And yes, x can be a negative number as long as that negative number makes sense within the purview of the question. Okay? So, another thing that you might see are decimal problems. And that's where things get a little bit nuts. I'll show you what I mean. But actually, before we do that, I'm just going to erase this. And, ooh, okay. So before we do that, sometimes you'll get a problem like 1 over, let's say, 25. And you're going to have another one that's like 5 to the power of, I don't know, 50x plus 3. And what you need to do in this scenario is recall your exponent rules, because again, you want this to have a similar base. So you want these to become the same thing, obviously. And the best way to do that is to take this 5 and figure out how we can turn it into 1 over 25. And the best way to do that is through a negative exponent. So I'm going to see how that looks here. So if I say 5 to the -2 to the power of 50x plus 3, and on this side I have 1 over 25. These brackets on the left side are not really necessary, but that's okay. And now I can rewrite this right side as 1 over 25. Or I can work the other way, which is actually easier. I just wanted to show you guys first how that looks. So this is another way we can write this. You can say 5 to the -2 on this side is equal to 5, 50x plus 3. And then in this case, it makes it much easier because now you can just go ahead and say -2 equals 50x plus 3, and you can solve accordingly, so you'll get negative 2 minus 3 equals 50x, and you get negative 5 equals 50x, and so on and so forth, and this becomes x equals negative 1 over 10. Okay? And again, if anyone is confused, you're more than welcome to leave a question in the chat, but we're going to move on to something else. But this is something that you'll see a lot, especially in the grade 12 level, but I think it's important to understand it in the grade 11 level as well. Sorry guys, I'm really tired. So let's take a look. So no longer looking at these types of questions. I don't know why I bothered erasing all of this. This is why the nib on my pen is starting to go. I have got to switch that out. Okay, so let's say you were given a question like 25b to the power of 6 to the negative 1.5. So whenever you're given a decimal, I highly recommend changing it into a fraction. So I know that 1.5 is another way of saying 3 over 2. And actually I should make that negative. That's a negative. And what we want to do now is actually multiply this in. So we're going to go ahead and do so. So we're going to get 25 to the power of 1 times that, and then b. So this is also like this. Great. So we've multiplied this into both of the bases here. And what we're going to do is we're going to get 25 to the negative 3 over 2, chill in by itself, leave it the way it is. And then here we've got b to the power of 3 divided by 2, or 6 times 3 divided by 2. So we're going to get negative 18. Now, like I always say, oh sorry, negative 9, what am I talking about? My bad. Alrighty, so we've got this. Now we need to fix the numerator-denominator situation, because technically this is all over the number 1, but this is not a flip. Okay, it's very important to remember that we're not flipping the numerator and denominator. We're just moving stuff that was in the numerator down to the denominator. And the reason we're left with 1 in the numerator is because technically you could say that this is all times 1 and you'd still be right. Okay, that's really important to remember as a math concept as well. So we've got 25 to the power of 3 over 2 and b to the power of 9. And I do not want to leave this unsimplified. So I have to go ahead and actually do the math on that. So it's going to be 25 to the power of 3 square rooted times b to the power of 9. And then basically we're going to get 125. So you get 125 b to the power of 9. Alrighty. So there's that. I want to make sure we're not missing anything else here, you guys. If anyone has questions about the stuff I have shown you, please feel free to let me know. So again, this is not like, you know, this is not the unit that's going to get you the most marks in grade 11, but it is one of the most important units to fully understand before you leave grade 11, because if you're catching up next semester, it'll be much, much harder. Sorry, next year for grade 12 advanced functions, it will be much harder. Alrighty. So if you guys are in grade 11 right now, and you have, I know that we're not doing exams this year just because of obviously everything that's going on, but if there are topics that you want me to cover over the next 4 weeks, please let us know, because obviously this is here for you. We want this to be conducive to what like your learning needs are and what it is that you need to really understand. So we've been following kind of our mini curriculum and doing the most important work, in my opinion. But if there's really a topic that you're struggling with at school right now, that your teacher might have assigned you, please do not hesitate to let us know. You can email it to us, or you can send us your questions in the chat. All right. So now, there we go. Otherwise, basically next week what I'm planning on doing for this unit is to do the word problems that are in this unit, because there's not enough time today to get all of that done, but there will be hopefully next week. Okay, so let's take a look. Actually, I think I switched the wrong page. Give me 1 second, guys, sorry. Okay, here's another quick type of problem that you might see. Sometimes you're going to get questions where they'll say evaluate and express each answer to 3 decimals. Now, if you have a really fancy calculator, there are ways to kind of finesse this, but if you don't have that kind of calculator, there are other methods, because you can actually punch stuff into your calculator much easier by using the rational exponent instead. So say you were given like 6th root of 2400, you could hypothetically change this, not hypothetically, in actuality, you could change this to 2400 over 1 over 6. And then if you were to put that in your calculator, even if you don't have a fancy calculator, you should be able to get the answer, no problem. Power of 1 over 6. So that's 4. Alrighty. Now let's take a look at something like 0.5 to the negative 0.5. So again, first thing I want to ask myself is, how can I convert this into what am I looking at? Rational exponent, so this is going to be negative 1/2. And then even without a calculator, I can kind of change this around to say, well, I'm going to call this 1 over 2 to the negative 1/2. And then I'm going to go ahead and multiply this in. So this is going to be 1 to the negative 1/2, 2 to the negative 1/2. And then we convert that by flipping it, because obviously there's nothing else that we can really do. So obviously these are on the wrong sides. This becomes this. And then I can convert this to this, root 2 over 1, because the square root of 1 is 1. And the square root of 2 is some crazy decimal, so I'm just going to leave this like this. And this is actually, I mean, in this case, they're asking for a decimal, so I wouldn't. Sorry, that's my bad. The answer would be negative or positive 1.414. Okay. Alrighty. So again, there are 3 forms. I just want to make sure that everybody understands this again before we do anything else. So there's the exponential form. There's the radical form. And then there's the evaluated form. So if you get a question like this, evaluation of expression is what I'm trying to say. So for example, if you get a question like this, where they've given you the radical form of something like this, and they've asked you to evaluate and to provide the exponential form, the best way you could do that is first to churn out the exponential form. So this would become 1/2 to the power of 9, all to the power of 1 over 3. And then naturally that becomes 1/2 9 over 3. And to evaluate this, you would come over here and do what I did on the last question. So you're literally actually bringing this in. You're going to multiply it into the numerator and the denominator. So you get 1 to the power of 9 over 3. And you get 2 to the power of 9 over 3. And then basically 1 to the power of 9 over 3, 1 to the power of whatever is always going to be 1. And 2 to the power of 9 over 3 can be rewritten as the third root of 2 to the power of 9, which I suggest you just plug into your calculator so you get 2 to the power of 9, and then you can do the third root of that answer and you get 8. So this is the evaluated expression. Okay. So again, I know that this seems quite simplistic, especially compared to some of the other work that we've done, but if we don't understand these fundamentals, it makes it much more difficult. So I like to go over everything and make sure people understand what's going on before we move on to doing word problems. Because the word problems for this unit can get real annoying real fast. Just to give you guys kind of a leg up on what's going to happen next week, I'll leave that up for a second and I'll just get the... So in grade 11, you guys don't learn about logs, but you do learn about kind of exponential growth and how it works in general. So I'm going to give you guys kind of a precursor to what's going to happen next week. And then if you guys want to come and see how we do the word problems for the stuff I'm about to talk about, please join us next Thursday because that's going to be a real help for you, especially those of you who are taking grade 12 advanced functions next year. It really is important for you to understand how the word problems work. So when we talk about exponential growth, there are a lot of things that grow exponentially. The population of bacteria grow exponentially. I know that's not the nicest sounding thing, but that's what happens. For those of you who might be interested in finance, there's many, many different forms of exponents in finance, and basically interest is a form of an exponent. But that's going to be kind of next week's discussion. But what I want you guys to understand that when we have exponential growth or decay, there are a couple things we want to keep in mind. So let's start with exponential growth. And the number one thing that we need to understand is that there is a base formula. So if there's y equals ab to the power of x, this formula is actually going to describe certain things to us. So for those of you who might be familiar with this, you know that it depends on whether you're talking about growth or decay. In this case, we're talking about growth, and we want to break this formula down into its pieces. So here we've got oh, dang it, my pen. This is our initial value. And for B, this is our growth factor. It can also be our decay factor, but what I want to make sure that we understand is that we know that it's a growth if the growth factor, this base B is greater than 1. Or equal to 1, realistically. And then it is a decay. Anyways, let me just make another point here. This is time, usually. But this can also be other things, so we're going to just kind of call this the number of times it grows or decays. And the reason I'm kind of doing a precursor this week is because next week we might not have time to go over every single little thing. I probably will do a quick refresher on this next week, but because we want to get into the word problems, and then we're only going to have 3 weeks after that, and I want to teach you guys trigonometric functions, I want that to be kind of our last thing. And even though we did trig identities already, the graphing of trig functions does take at least 3 classes. So I kind of want to get us to complete this unit as much as we can. Okay, so anyways, this is exponential growth. If we have an exponential decay, it's basically the same formula, except this becomes y equals a times 1 over b to the power of x. And we call b the factor. Okay. So we're not going to get into this today because it's too much. We won't have time in the next 3 minutes. But if anyone has any questions, feel free to drop them in the chat. If not, or like if you even have questions about stuff that we did earlier, then let me know. But if not, I hope that today was helpful for you guys if you haven't done this unit. If you have done this unit, I highly recommend just kind of making sure you understand all the laws, because they will be helpful to you down the line. And I will leave you guys with one more simple, quick question. Hey, I'm so tired. Alrighty. So let us try this question really quickly. Where did it go? Oh. 25 to the power of -1 plus -5 over 2 to the power of -2. Great. So 25 to the -1, we can automatically change that to this. And then last but not least, we are going to take a look at these pieces in here. So because I want to keep things standard and I don't want to have a decimal, I'm not going to do the division there, but I will have -5 to the power of -2 over 2 to the power of -2. And I need to fix that. Obviously, there's a lot of stuff that needs to be fixed here. So I have 1 over 25 plus -2 squared over 5 squared. That's a squiggle. Okay. And then we can fix this to be 1 over 25 minus 4 over 25. And then we get -3 over 25. Alrighty. So that's everything for grade 11 today, you guys. I hope you have a wonderful afternoon, or what's left of the afternoon. I hope you're staying safe out there and everyone is staying healthy. And yeah, so I'll see you all again next week, hopefully. And if you do have questions in the meantime that you want to submit, just feel free to drop them in the chat. Alrighty, so thank you guys very much, and I'll see you again next week. And if you'd like to stick around for the grade 12 class, you're more than welcome to. But if you want to take a break, I totally understand. Have a good one, and I'll talk to you again next week. Thank you. Okay, so it's 5 p.m. If you are joining us for the grade 12 class, I'd like to say hello. We are going to be wrapping up our unit on graphing trigonometric functions and all of that boring stuff. So without further ado, I will get started. But before we do that, I shouldn't have said without further ado. Before we do that, I want you guys to write down this formula and keep in mind that this also can be a cos formula. So that we can get started, and then that way we don't have to constantly be rewriting it. Okay, so just give me 1 second here, you guys. Alrighty. So in this unit, you're going to get a lot of word problems, and this is kind of where most people struggle in this unit, just for, the fact that the word problems can be quite intense. You'll have two types of word problems. The kind that we did last week are ones where um, you're basically determining the equation based on the word problem. Now, this week we're going to go one step further and take a look at a couple of other things. So let's just type this first problem here. The average depth of water at the end of a dock is 6 meters. This varies 2 meters in both directions with the tide. Suppose there is a high tide at 4 a.m. If the tide goes from low to high every 6 hours, write a cosine function, distance as a function of time, describing the depth of the water as a function of time with t equals 4 corresponding to 4 a.m. At what 2 times within one cycle is the tide at a depth of 5 feet? So we've been given a lot of information in this question, and what we want to do in those scenarios is break down the info as much as we can. I'm going to actually separate this so that I can make the text bigger. Great. So let's move this. Oh gosh, it's still too much. Oh, I hate when it does this. All right, it's not going to get any bigger, you guys. I apologize. So anyways, basically, let's take a look at what's been told to us and how we can use that information. So the average depth of water at the dock is at the end of the dock is 6 meters. So oftentimes you will get tide questions because tide often follows a sinusoidal function in general. Obviously, tides change with the moon and all of that fun stuff, but overall tides tend to follow a sinusoidal type of function. It has that periodic, they have periodic quality to them. So, basically they're saying the average depth of water at the end of a dock is 6 meters. This varies 2 meters in both directions with the tide. So what they've actually told us is, like, if we're picturing this as a sinusoidal function, the first thing I want to say to myself is, oh, they've actually told me what my midpoint is, right? Like, let's say arbitrarily that this is the function. I know that doesn't look great, but they've told me what that middle line is, and we know that to be the C term. So what have I been given? Well, first and foremost, when they tell me the average of something like that, then I've been given C. So I know that C is positive 6. And we know that this varies 2 meters in both directions with the tide. So we've actually been given 6 plus 8 is the max, and the min is 6 minus 8. Oh, no, not 8, 2, sorry. So again, these types of questions are not as hard as they make them out to be. Just break it down piece by piece. So 6 plus 8 plus 2, which is 8, which is what my brain was trying to do earlier. And then the minimum is 6 minus 2 equals 4. Okay, so what they're saying, suppose there is a high tide at 4 a.m. So I'm going to pull up one of these bad boys. Actually, cancel that. Expand. Oh, it did it on another page. Hold on a sec. Oh my gosh. Well, let me just copy paste this information over here. Cool. That's fun. Let's expand this. Let's move this just so that we can see everything. There we go. We can finally expand this properly. And I'm just going to expand this, not like that. Dang it. Now it's not straight. Anyways, point of the story. We just need this to graph with, so let's do that. So because this is a cos function, I'm just going to use this type of graph that starts at 0 on the x-axis. Now, when you're graphing this for realsies, you're going to want to make sure that you're showing that this is distance, that's time, and this is distance. And you're going to want to indicate that on your graph. So distance in meters and time in hours. Okay, so they're telling us to start at 4 a.m. We already know what our max and our min are, so we have the C term. The C term is 6. The max and to get the A term, we're going to go 8 minus 4 divided by 2, which is 2. So we're going to get A. And if you're confused by what I just did, please feel free to go back and watch last week and the week before's video on how to get the A term and the C term. For those of you guys who've been sticking around, you know that it's pretty much just max minus min divided by 2. Okay, so suppose there's a high tide at 4 a.m. So that tells me, let's see here. I would like to do this by 2, 4, 6, 8. And that means that I'm starting my cosine function right here, and I'm going to call this 4 a.m. And if the tide goes from low to high every 6 hours, write a cosine function describing the depth of the water as a function of the time with t equals 4 corresponding to 4 a.m. So let's just move everything over quickly. Okay, so there's a couple things we need to determine here. It says that the tide goes from low to high every 6 hours, but we want to know how long it takes from high to high, because that is one period, which means that our period is our period is 12. And the way that we can kind of take that information and make it functional for us is to look at our period and k equation. So period equals 12, and we know that the period equals 2 pi over k, and that means that k equals 2 pi over the period, which is 12. And that means that k is pi over 6. So far I've got my equation as y equals 2 cos pi over 6 and then here I need to put t, sorry, this should be d of t, and I need to determine the high tide, basically, right? So now in this sense, we want to make sure that we know where the t is. So actually I made a mistake here. I shouldn't have made 4 a.m. my 0. Just gonna make that, erase that, put a little line there. I'm gonna make 12 a.m. my 0, because basically it's important to understand that we're moving by 4. And the reason is because the high tide starts at 4. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18. Perfect. That means that here at 4 hours in, which is at 4 a.m. technically, my tide is at its high point. Wonderful. And that means that 12 hours from now, at 16, we're going to be back at our high point. So for those of you who struggle with graphing cos functions, you literally just, if you know your high points, then you can just find the midpoint to be your low point, and then the midpoint of those midpoints to be the situation where you're, oh, hold on a second. So that midpoint here, yep, 10. And then the midpoint between 10 and that, so 7. And here it would be here. Here it would be here. Yeah, so this is our function. So how did I get this function? Again, I have been given all of the pertinent information, and it's just about extrapolating the pieces that matter to us. So what did we do in this scenario? First things first, they told us the average depth of the water. Whenever they say the average whatever, that means that it's the midpoint. That means I know my C. Then they told us this varies in 2 meters in both directions with the tide. That means it goes up by 2 meters, down by 2 meters, which gives us our max and our min. Our max is 8. Our min is 4. And for the A term, I just did 8 minus 4 divided by 2, and I got 2. So there you go. A and C are done. Next, we need to determine what our phase shift is. And when they've told you that the high tide is at a certain point, and they've asked you to do a cos function, that means that you know your cos function starts at 4, and you have to indicate that. If the tide goes from low to high every 6 hours, that means that that's half of the period, and we use that information to get 12, and then plug that in to solve for k. Now we need to do the final part of this question, so I'm going to do some erasing to get rid of this extra garbaggio here. So they're also asking at what 2 times within one cycle is the tide at 5 feet. Okay, so that's actually something we can work backwards with. Alrighty, so keep in mind that when you're solving for this, that means that you've actually been given the distance or the height of the thing, which means that that's actually the answer, and you're solving for the time, right? Now, in general, you can kind of see when it's at 5 feet. It's like on your graph, you can see when that's happening, but you need to actually give the real answer. So let's go ahead and plug stuff in. So, give me 1 second here, you guys. Okay, so in this scenario, actually, let's move everything up a little bit, if I can. Just erase this. Okay, so let's take a look here. We've got the answer, so we've got 5 is the number that is the height of the tide, or the distance, or whatever. And then we can actually take our equation, which, let's bring the equation down. So the equation is distance as a function of time equals 2 cos pi over 6 times t minus 4. And it's minus because we're moving in the positive direction. It's always the opposite. You know how it is. So they want to know at what 2 times within one cycle is the depth is the tide at a depth of 5 feet. So that means we have to make the answer, this part, 5, and work backwards. So my original situation here. So these are actually the kind of the main types of questions you will get as word problems, and it's best to just work backwards essentially. So we're going to go, algebraically, 5 minus 6 equals 2 cos pi by 6 t minus 4. And then you're going to divide 2 off of both sides, so you get 5 minus 6 divided by 2. Okay. And you're basically here, you're left with cos pi by 6 t minus 4. And at this point, you can technically divide cos off of both sides to get the cos of -1 from from, or the cos of a half, so I'll show you what I mean. So 5 minus 6 is -1, divided by 2 is -1/2, and we're going to have the cos of this. So basically at this point, you're going to go cos to the -1 on the other side, and what's really happening is you're dividing cos off of both sides, but in actuality, you're solving like this. So cos to the -1 of -1/2. And for those of us who've got our unit circles near us, you basically just take a look at where is cos -1/2. And then this side of the equation is left as pi by 6 t minus 4. So cos is equal to -1/2 in quadrants 2 and 3. And basically that means that at 2 pi over 3 and let's just move all this stuff down. So, oh, gotta erase some more. So cos is equal to -1/2 at the angles 2 pi over 3 and 4 pi over 3. So using that information, we now have two answers, obviously, because this is sinusoidal. So we're going to go ahead and use those two answers. So this part goes like this. 2 pi over 3 equals pi by 6 times t minus 4. And 4 pi over 3 equals pi by 6 times t minus 4. And then we just go ahead and solve. So in this case, you can either go 2 pi by 3 divided by pi by 6 equals t minus 4. And then that just becomes 12 over 3, which is 4. That becomes 12 over 3 because you're multiplying. You're going to flip the fraction and multiply. Okay, guys? Those pi's cancel, and you just get 4 equals t minus 4. And then on this side, you're going to get 4 pi by 3 divided by pi by 6 again equals t minus 4. And again, you're going to flip that fraction. The pi's are going to cancel. You're going to get 24 divided by 3, which is 8, equals t minus 4. And then finally, as your final answer, just solve algebraically. You're going to get t equals 8 and t equals 12. So if you get a question like this, you guys, it's imperative that you do these steps. You use your knowledge of the unit circle. If you're finding yourself confused about the unit circle, practice your special triangles. And if you have missed other weeks, just go back and watch previous weeks. I talk about all of this stuff in other videos, way more in depth, so that you can understand everything. Whee. Okay, so that one's quite a doozy. But basically the answer is 8 a.m. Answer is 8 a.m. and 12 a.m. or 12 p.m. at noon. Cool. Alrighty, guys. Let's try another one of this type of question. So let's type it in here. Oh, I should be putting in some spaces. So here we go. This is also a common type of question. That's why I'm going to do this one. And it's really important to understand these oscillation questions. Oh gosh. Oh my lord. Let's fix this. There we go. Determine. Let me just fix that. Then find out what 2 times within 1 cycle is the spring at 1.5 feet above its rest position. Okay, so we've got a lot going on in this question, but that's okay. We can figure it out, you guys. Also, I should just copy paste this because I'm going to need to put in a thingy here. Put in a graph. Okay, oh, it didn't do that. Great. Oh gosh. Okay, so there's this. There's our graph guy. Oh my gosh, I keep doing that. I keep forgetting that you have to expand it this way, not the other way. Okay, so a mass is suspended from a spring. A mass suspended from a spring is pulled down a distance of 2 meters from its rest position. The mass is released at time equals 0 and allowed to oscillate. If the mass returns to its position after 1 second, find an equation that describes its motion. Then find out what 2 times within 1 cycle is the spring at 1.5 feet above its rest position. So, if the mass is suspended from a string and pulled 2 feet from its rest position, so the rest position would obviously be this. So if it's pulled 2 feet from its rest position and released at time equals 0 and allowed to oscillate, then we need to determine all of this other stuff. So first of all, in this scenario, oh, a mass suspended from a spring. I didn't read that part. Either way, it's fine. Basically, we first need to determine our max and min, which is important. So we also know that basically it returns to its position after a certain point. Now, time is going to be our x, and the positioning is going to be its y. Now, in terms of that, let's put in some lines here. Get my lines in. Okay, there's that. And then I've got this. And I've got this like this. Gotta make sure it's all positive. This is time. This is, we'll just call this y, call this x, and then name this time. Okay, and then this is distance. So first things first, if we know that the mass is released at time equals 0, that's really good. That tells us that we're going to start somewhere over here. This can be 1 or -1. This can be -2. This can be 1, and this can be 2. So basically what this is telling us is that from its rest position, it's pulled down, because this is a spring. The spring is pulled down to 2 feet below its rest position. And then, assumedly, it returns to its position after 1 second. So basically at this point, we need to determine that this is the rest position. It gets pulled to -2 below, because we need to set this up as a, this is -y. Obviously, if you've taken physics, you know about this kind of stuff. If you don't, basically in a situation like this, you always want to set up a negative and positive y. And then from there, you essentially go in and you have to say to yourself, well then, if the rest position is 0, realistically it would also go up to above 2. So, in this case, at time equals 0, we've got -2 there. I also want to put in my numbers here. So this is going to be, this is going to be 1. This is going to be 2. Okay, so we've got time equals 0. Now, keeping this in mind, we now know that if our equation is going to be a cos equation, which would make sense because it's not starting from rest, it's starting from -2, we first and foremost need to make this into, actually give me 1 second, guys. I'm going to make this into a sine equation. So we're going to get rid of that thing that I drew here, this dot, and do this again. 1, 2. Great. So now, basically, we want to determine a sine equation. So if our equation is y a sine k x minus d plus c. Oh god. Oh, I hate that. There we go. X minus d, that's a minus, plus c. Basically, we've been given a couple of things already. We know that the minimum, sorry, the c term is 0 because that's our midline. And then we also know that the max would have to be +2 and the min would have to be -2. So to get our max minus the min to get a, it would become 2. So the a term is 2. Got a sine function here. Now, we also need to remember that we have to figure out the period. So the mass is released at time equals 0 and allowed to oscillate. If the mass returns to this position of time equals 0 after 1 second, time equals 0, after 1 second, then basically we come back to this at 1, then essentially we can figure out our period. So just give me 1 second here, guys. I want to make sure I'm showing you all the right steps. So basically our period is 1. Alrighty. So keeping that in mind, that means that we go from 0 from -2 back to -2 within 1 second. And in the halfway point, we're going to have to get to the top here, and here, and here. So here we have our graph. 1 cycle of our graph. This here is 0.5. And obviously it would continue, so it's not just going to look like a pointy thing like this. It's going to go on back to this, like this. So here's 2 cycles of our graph. Oh. Sorry guys, it's just really hard to draw with these. Anyway, so this is what that it looks like. And at this point, we also are saying to ourselves, well, for this to be a sine function, we have to know at what point is the midpoint happening, and that's at 0.25 right here. So that's going to be x minus 0.25. And then the period we know is 1, so we're going to get our k value is 2 pi over the period, which makes k equals 2 pi. So this is our equation. Y equals 2 sine of 2 pi x minus 0.25, just like that. We could also create this as a cos equation. We just basically would determine at what point does the peak happen, which is at 2, and that would become our cos equation. It could also be y equals 2 times cos 2 pi, and it's just about the difference in the phase shift, like that. So we still haven't answered our full question though, because what we're really looking for is what 2 times within one cycle is the spring at 1.5 feet above its rest position. So let's make some space here. Let's erase a bunch of stuff. Because basically, like I've said, these are going to be the bread and butter of the type of questions you guys get in this unit. It's really important that you understand how it all works. So these are our 2 equations. I'm going to make some more space. It's so satisfying to erase these. Goodness. Do that. Do this. Time in seconds. Great. Now, let's go ahead and solve this. What we're really looking for is the y term, like plugging in the y term and then solving for x, which is very, very easy to do. It just involves working algebraically backwards. So basically they're asking at what point is the spring at 1.5 feet above its rest position. So if we've got 1.5 equals, I'm going to use the sine function, 2 sine times 2 pi times x minus 0.25. And then let's just work backwards. So I'm going to divide off the 2, so we get 1.5 divided by 2 equals sine 2 pi x minus 0.25. And then we're going to sine to the negative 1 on both sides. So 1.5 divided by 2, you could solve for that if you wanted to. 0.75. So if in this case we would go sine to the negative 1, 0.75, and I would just plug that into my calculator. So I get 48.6 here, and obviously using the sinusoidal properties of the unit circle, we know that if I was to go 180 minus 48.6, I would get the other side. So let's just... Okay, so let's go ahead and look at the 2 answers to this. So you get 48.5 and then also 180 minus 48.5. So on this side you're going to get 131.4. And that's going to technically be the answer that you're working with. So you have to get the answer for both of these things because, again, we're looking at a sinusoidal function. So let's solve it for 48.5. So 48.5 equals 2 pi over x minus 0.25. And all that's going to happen here is you go 48.5 divided by 2 pi equals x minus 0.25. Make sure you've got yourself in radians mode. And then you just go ahead and divide it off. Actually, no, I lied. Let's not bother with radians mode. You have to switch the 2 pi to 360. Sorry, guys. So this is going to be 360 times x minus 0.25. And you're just going to divide 360 off of 48.5. And you're going to get, let's put our calculator in degrees actually. That was my bad. Minus 0.25, sorry, plus 0.25. Because you're moving it to the other side. So x here equals 0.38. And let's do this one. 134 equals 360 times x minus 0.25. And I'm just going to put these to the side kind of on their own situation. And then basically same thing, 131.4 divided by 360. And we will get x minus 0.25. Keep writing that backwards. And then our next step is going to be 131.4 divided by 360 plus 0.25, and your time is 0.62. So x equals 0.62. So these are your two times. T equals 0.38 and 0.62. So these are not as difficult as they seem. It's just about working algebraically backwards. Be very careful as you're putting these together because you have to be cognizant of when you're using radians and degrees. So if anyone has any questions, I'll leave that up for a second. If anyone has any questions, let me know. Okay. Alrighty. Now, since it doesn't look like anyone has any questions, we're going to move on to another example. Okay. We're going to do another tide example because it shows the other type of word problem that you would have in this scenario. Actually, let me make this a separate thing. So at high tide, the water level at a particular boat dock is 9 feet deep. At low tide, the water is 3 feet deep. On a certain day, the low tide occurs at 3 a.m. and the high tide occurs at 9 a.m. I know that I should be putting dots with a.m., but I'm lazy to do that. Find an equation for the height of the tide at time t, where t equals 3 is 3 a.m. What is the water level at 2 p.m.? Okay, we've got a lot of different pieces to this situation. So let's dissect this sentence by sentence. So at high tide, the water level at a particular boat dock is 9 feet deep. At low tide, the water is 3 feet deep. On a certain day, the low tide occurs at 2 a.m. and the high tide occurs at 9 a.m. Great. So we've been given some very key pieces of information. Let's look at it moment by moment. At the high tide, the water level of a particular dock is 9 feet deep. So that is our max. So let's write that down. We know max is 9. At the low tide, it's 3. On a certain day, the low tide occurs at 3 a.m. and the high tide occurs at 9 a.m., which is a 6-hour difference. And we want to know, in general, when we look at periodic functions, how long it takes to get from low to low or high to high. So realistically, our period is 12 hours. Find an equation for the high tide of the time at of the height of the tide is what I'm trying to say, at time t, where t equals 3 is 3 a.m. Not a problem. We can definitely do that. I'm not going to use those graphs because they're just annoying. So I'm just going to do this and try to make these lines as straight as possible. Wonderful. Okay. So let's say we've got this. Let's say I have 3, 6, 9. Great. And then here I've got 3, 9, 15. So the reason I'm writing these as numbers, not as times, is because when you're talking about time, you cannot write them as numbers. Like, you have to actually put the time. I know that sounds Like I'm just repeating myself, but it's very important to remember that. So this is x, this is y, this is time in hours, this is height in feet. This is an American question, but that's okay. The concepts are the same. So, first things first. We have been given some important information here. Like I said, we have the max, we have the min, we have the period, and we need to take that information to heart. So basically, what are we missing is really just the phase shift, which we will figure out in a moment. But first things first, I want to determine whether I want to make this a cos function or a sine function. And what I'm going to look at is how they want us to determine what's going on. So an equation for the height of the time at t, where t equals 3 is 3 a.m. So basically what I'm going to do is say to myself, well, at 3 a.m., they're basically telling me that the low tide is what's happening. And we know the low tide is here at 3. And I know that it reaches the high tide at 9 a.m., which is 9 hours after midnight. So that's right here. And then it comes back to the low tide 6 hours later on the 15th hour, which I think is 2 or 3. 3. That makes more sense. Anyway, point of the story. Let's get to work here. So if I'm going to make this a cos function, which I am, I first want to say to myself, well, the phase shift is basically based on where the function is at its high point, and the function is at its high point at 9. So this is one period of this function. So let's go ahead and plug all of our numbers in. The a term is 9 minus 3 divided by 2, which is going to be 3. The c term is going to be 9 plus 3 divided by 2, which is 6. The the k function is going to be 2 pi divided by 12, which is going to be pi by 6. And that's pretty much what we've got there. And I also know that the phase shift is going to be negative 9. So let's go, or 9 technically, and it's going to look negative in here. So you'll see what I mean. So we've got 3 cos, and then in here we're going to put pi by 6. Remember to bracket that. X minus 9 because you're moving in the positive direction. Close that bad boy off. And plus 6. Yay, we did it. Now, this is also another way of saying this is height as a function of time. The x can be a t. It doesn't really matter. It depends on your teacher, but for the most part, it doesn't really matter. Find an equation for the height at a time, blah, blah, blah. So, what we want to do now is sub in the time and find out at what height, or sorry, yeah, plug in a number for the time and determine that. So first of all, we want to determine how many hours after 12 a.m., aka midnight, is 2 p.m. So 12 to 12 is 12, obviously, and then you add another 2, so you get 14. So just for anyone who might be confused by what I said, 12 a.m. to 12 p.m. is obviously 12 hours. And then plus 12 p.m. to 2 p.m. That's another 2 hours. Well, 2 hours. So altogether that's 14 hours. Great. So basically at this point you are just going to plug in 14 hours into your equation. Yay. Let's erase that. So t equals 14. So we're going to get 3 cos pi by 6, 14 minus 9, plus 6. So let's go ahead and do this piece by piece in terms of bedmass. Bedmass is our number one guy. We always want to be following bedmass. So 14 minus 9, you're going to get 5. And then that's basically the same thing as saying 3 cos of 5 pi by 6, which we know is something we can solve from our unit circle So let's take out our unit circle. And at 5 pi by 6, oh, 1 second. Our cos is going to be negative root 3 over 2. So this becomes 3 times negative root 3 over 2, because now that's what cos of that number is, plus 6. And then that's going to become negative 3 root 3 over 2 plus 6. And then this is going to become negative 3 root 3 plus 12 over 2. And if you want to go in and solve this, you can. Actually, this is actually the most correct way to leave it. But if you have a teacher who wants like an exact decimal number, you can go ahead and do that. So negative 3 plus 12 divided by 2. So you should get 3.4 as your final answer if you're giving them a decimal. 3.4 feet. Okay, anyone who might be confused by that, feel free to leave a comment. But for the time being, that is just going to be left up for a couple seconds so you guys can copy it down. Okay. So you guys, I think we have time for one more question. If anyone has questions that they want to bring to the equation, the situation, I mean, feel free to drop them below. But yeah, these are the two main types of questions you're going to get, where they give you a word problem. Tides are a huge one. They give you that word problem and you have to solve using all of the pertinent information. Okay. Let's do one more doozy, and then we will be all done. So, city averages 14 hours of daylight in June, 10 in December, 12 in both March and September. Assume that the number of hours of daylight varies sinusoidally over a period of 1 year. Write an expression for n, the number of hours of daylight, as a cosine function of t. Actually, let me make that a next line. As a cosine function of t. Let t be in months and t equals 0 correspond to the month of January. What is the average amount of daylight hours in August? Okay, so this is actually also a very common type of question you might get. This is quite a doozy, but again, we're going to break it down piece by piece, so don't worry about it. So again, whenever we see the word averages in these types of questions, we just automatically know they've given us the C value. But we also want to make note of what the max and the min are. So first things first, max is, or sorry, 1 second. Sorry, I meant to say averages if they say it in general, but in this case they're saying just for a specific time. So actually 14 is the max. And the min is 10. Yeah. Which makes sense because in December obviously the days are short. So we're going to get our A term. That's going to be 14 minus 10 divided by 2, which is 2. Our C term is going to be 14 plus 10 divided by 2, which is going to be 12. Now, let's go ahead and take a look at the period. Now, in this case, it's just 1 year. So actually, it goes from max to max within the period of 1 year. So in this case, the period is 1. And the k term is going to be 2 pi over 1. So it's just 2 pi. And then they want us to create a cosine function, which means they want it to start at the maximum. And the maximum occurs in June, which is 6 months after. Hold on a sec. Yeah, which is 6 months after the start date. I just want to make sure that I'm actually using 6 properly. So actually, in this case, it's going to be 5, and I'll show you guys why. Sorry, that's what I was kind of silent about. I wanted to check something. So this is one way to write this, and it's can be kind of confusing, but basically you're saying that January 1st is t equals 0. So this is j. So if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is February, March, April, May, June, July, August, September, October, November, December, and then January again, back at 12. So technically this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, back with January 1st being the 12th month, right? So keeping that in mind, that actually makes June the 5th month. So if our numbers go from like 14 being the max, right? And then we've got 10 and 12 in the middle. So then here in June, that's our max value right there. Oh, I made that kind of sloppy. That's okay. And then we're back at it the next June. So, but also keep in mind that December is our low. So somewhere over here is that other low, which means that basically you've got this looking like this kind of. It's a very wide cosine function. So keeping that in mind, our d, or our phase shift, is actually going to be 5. So that's going to be written like this. Y equals 2 cosine times 2 pi bracket x minus 5, because that's where the max is, and then plus 12. Great. So we've written our expression as a cosine function. That's wonderful. That's what we wanted. Let t be the months. Let t be in months, and t equals 0 correspond to the month of January. What is the average amount of daylight hours in August? So August is our 7th month, which means I just plug 7 in as x, or t, whatever you want to call it. So y equals 2 cos 2 pi, put those brackets in, 7 minus 5 plus 12. And here we go. We're going to get 2 cos of 4 pi plus 12. And we need to recall that 4 pi is the same cos as 2 pi, so that should be 1. So 2 cos of 4 pi is 1 plus 12. Oh, I'm sorry, guys. Because we're doing this in months, this k value should actually be 2 pi over 12 or pi by 6. So let's just fix that. So our k value, so this is actually 12, and then this is 2 pi by 12, or pi by 6. Sorry guys, I didn't mean to confuse you. So this is actually different. If anyone's confused, just like virtually raise your hand, I guess, or just let me know in the chat and I'll re-explain what I just was talking about. So anyways, this becomes 2 pi over 12, or sorry, 2 pi over 6 plus 12. And then we can actually find 2 pi over 6. We can find its situation, because really it's pi by 3. So the thing of pi by 3 is a half. And the cos of pi by 3 is a half. So basically this is 2 times a half plus 12, and then this equals 13. So n equals 13. And basically that is how you solve this type of question. So sorry about the mix up there, guys. I was looking at the wrong thing earlier, but basically the same rules all apply, and you are all set, my friends. Okay, I'm going to leave that up for like 30 seconds, and then basically we don't have enough time to do another question, so if anyone has any questions they want to submit, let me know. But otherwise, we're going to wrap it up for the day. So thank you very much to everyone who joined today. I hope you're having a wonderful week, and I will see you again next week, hopefully. And in the meantime, stay safe and have a wonderful weekend. Have a good one, guys. Thank you so much. So I'll leave this up another 30 seconds, and then I'll shut down the live, okay? Have a good one. Bye.